We're going to make some more connections today in our lesson on minimums, maximums, and the axis of symmetry. We're going to use the vertex of a parabola to help identify if we have a maximum or minimum. We know how to do that on a graph, on the table, or in an equation, and we'll be able to represent that as a value. And we'll use two different methods from the lesson itself to identify the axis of symmetry in an x equals form. So that's going to be key. So let's start by just taking a look of identifying a maximum or a minimum on a graph. So nice and easy. So with a graph, we can clearly identify whether we have, in this case, a minimum, because that is our lowest point. And here our vertex is our maximum. It is our highest point. So that's the easy part. And now I want you to start connecting to when we talked about range before and identifying, so what is that point, the maximum or minimum point? Well, let's start with the one on the left. We have our vertex as -3, 0, and we're thinking about our range, right? So in this case, our minimum is just 0, because that is our lowest point here. Whereas in this one, we have our vertex, but the highest value, our maximum, is going to be 5, because that is the highest point there. So graphs are easy because you can literally just see it and tell if it's a minimum or if it's a maximum. And it's easy because you can see if the graph is going up or if it's going down. But what if you can't see? What if you can't see that? So let's look at, let's say, an equation form where we can't see if it's going up or down. Well, this, my friends, is where the A is super, super helpful, because the A in our vertex form equation is going to tell you if it is going up or if it is going down. So taking a look here, now these are not written in that form, but looking here in this point here, A is a positive number, just +1, and here A is a negative number, -1. So what do you see? What do you notice? Well, when A is positive, your parabola opens up. When A is negative, it opens down. So we're going to just use that. So when A is a positive, you know your graph is going to go up. When A is negative, it's going to go down. So using that information in the first one on the left, I have here A is just +2. So I know my graph is going to go up. So I know that whatever my vertex is, this is going to be the lowest point. This is going to be a minimum. And on the other side, here you can see it, that negative. So I know A is a negative number. So I know it's going to go down. And so my vertex is going to be the maximum. So that's really helpful for us to know. So given that, now let's just use what we already know. We can figure out what the vertex is going to be, right? Actually, I don't even need the entire vertex. I just need that Y, or I just need K. So in this case, because I know the vertex is HK and K is -7, my -7 is my minimum here. And on the other one on the right, we're going to look at K again. K is positive. K is +6, so my maximum is 6. So you see how super helpful this is, our vertex form? That's why I love it. And again, if you have it just in a regular standard form, moving into vertex form is super helpful. So here you go. This is how we can identify using our A and using K to figure out our minimum and our maximum. Hit pause and jot this down. Let's talk axis of symmetry. We haven't talked about symmetry probably since you were a lot younger, and that's usually when you can cut something in half or fold it in half. So in our definition, we're going to talk about it as Algebra 1 students. It is the vertical line that splits the parabola in half, that halfway point. So it's really helpful to identify your vertex, because that vertex, that turning point, is that halfway point. All right, so that's how we can identify it, that turning point, and is that folding point. And so it's going to be a vertical line that passes through the vertex. So again, our vertex helps us find where it is located, but we're going to have a line going right through it, slicing it straight down. So let's look at our first example right over here. Here's our vertex. So our line of symmetry is, I'm going to cut it right in half. So let's do that. Boom, there it is. That is our line of symmetry. It cuts right through and it cuts it in half. So what our line of symmetry is also going to do is we want to write this down as an equation. This is x equals 3. That's my equation. So it is all the points where x is equal to 3. And I can use the x coordinate of my vertex to figure out my line of symmetry. So looking over here, again, I can use my x coordinate. Actually, it's the same number, 3. So that's going to also tell me where I'm going to throw that line down through the point. There you go. And you have it again. This is where x is equal to 3. Now, another way, let's say like you can't even see the point, you don't have a vertex. So I'm going to just play devil's advocate, pretend we don't see this. Like we see a point, but we can't tell what it is. What you could do is you could just take these 2 points where the zeros are, and you can find the midway point between those 2 zeros. Okay, so watch what I mean. I can take this point and this point here and find out what is halfway. So I'm going to take, let me just write this down, 1x, and here's 1 0 and 5 0. Here are my xy's. So I'm just going to add my 1 and my 5 together. I'm just going to divide it by 2. So 6 divided by 2 gives me 3. And so x is equal to 3 becomes my axis of symmetry. There you go. They both work. So that's just a second method. Now you have 2 of them. One, you can just kind of just use that value over here, the x coordinate if you have that point. Or 2, you can, if you have 2 points, you can take the x values to find the halfway point. And that will give you the axis of symmetry. So this is helpful whether you have a graph or if, let's say I give you a problem that only has 2 points. If I give you 2 points, you can still find the axis of symmetry even though you can't physically see it. All right, so hit pause and jot this down into your notes as well. All right, and now it's time for you guys to do some practice on your own. Hit pause and try to identify the minimum, maximum, and axis of symmetry of these 2 problems. All right, that was your spoiler warning. Spoilers coming up. Let's go through the first one. So do we have a maximum or minimum? Here we have a minimum, and our minimum value is at -6. That's our lowest point. That's our y value. So, and what would our axis of symmetry be? In this case, it is just -1. So I would just draw it out. Boom, there you go. So x is equal to -1. Let's put that in there. And our lowest value here would be at -6. Let's look at the second one. Here we have the opposite. We have a maximum. And our maximum value in this case is going to be 1. There it is, 1. And our axis of symmetry is just at when x is equal to 0. And I can just see it right there because it's literally on that y-axis. All right, well, that's it for today's lesson. I hope this made a lot of sense to you. Again, use your criteria for success to get feedback and get some practice in. You're going to see tons of graphs today, and we're just learning how to write down a proper notation and identify maximum and minimum. That's it for today. I'll see you in the next one, Math Marvels. Be well.